Welcome everybody to our webinar today. The BCA is excited to give everyone a sneak peek at the exciting tools and technology scheduled for NCBC this year. Our exhibitors are gearing up to present these webinars and their presentations for NCBC. Over the next few weeks, we're going to have a few more of our exhibitors presenting, and we hope that you can join us for those also. But today, we're excited to have Brent Baird here today to talk to us about ultrasonic flow meter technology for commissioning, balancing, and HVAC. Brent Baird has 37 years of experience in ultrasonic flow meter technology, hydronic applications, and is considered a historian and spokesperson for ultrasonic meter industry. In 1977, Brent and his father, Jim Baird, founded Dynasonics and the manufacturing of ultrasonic flow meters. They sold that in 1996, and Brent founded Instruments Direct, an engineering firm specializing in the sales, rental, and engineering of many brands of ultrasonic flow meters. Because of his unique experiences, Instruments Direct also provides R&D engineering and beta testing of the top ultrasonic flow meter manufacturers. The collaboration has resulted in the development of many value-added features and custom meters. In 2008, Brent founded Non-Contract Meters and manufacturing of ultrasonic flow meters. Although Brent is the CEO of both companies, you will find him manning the phones as a senior applicant engineer, presenting a webinar, and touring the country as a professional technical speaker. So today we're excited to have him here to talk to us, and you will also see him at NCBC in St. Louis. And with that, I will turn it over to you, Brett.
Thank you, Liz. Can you hear me now?
We can't hear you. Just
sounds like a telephone commercial. Can you hear me?
Yes, you're all good. Thanks.
Can you hear me now?
Yes, Brett.
How about that? All right. Can you see me now? There we go. Meeting is now in progress. Thank you very much for the opportunity to speak to this illustrious group today, where we are across the globe there. Today we're going to talk about a few things, and first thing we're going to talk about is sound. Sound is a mechanical wave that's an oscillation of pressure transmuted through some media like air or water. It's composed of frequencies within the range of hearing. Now, ultrasound is a frequency greater than the upper limits of human hearing, traditionally greater than 20 kilohertz. But on the other hand, have you ever heard a dog whistle? And that's because a dog whistle uses a different frequency that most humans can't really hear. Although if I digress back in my high school days, I did have a girlfriend, and I'll bet you money if somebody blew the dog whistle, she'd probably come running. Well, I'm getting off topic already. Let's take this the next further. No, and we're not watching an episode of The Outer Limits. We're looking at sound as it's represented on an oscilloscope. So the question is, can we use sound to measure liquid flow? And of course, the answer is you betcha. And that's why I'm here today. We're going to talk about ultrasonic flow meters. And this technology can measure the velocity of a fluid with ultrasound and calculate the volumetric flow from the outside of a pipe. Now, how neat is that? Well, we have our ultrasound, but in order to measure flow, we need to add another ingredient. And the other ingredient we need to add to the equation is time. Hence the term ultrasonic transit time flow meter. Not to be confused with ultrasonic Doppler. We'll touch that a little later. So how does ultrasonic transit time theory actually work? Well, just like any good story, starts out with a man on a rowboat. So as we go forward here, we have a man in the rowboat, and he would like to cross a river. So he gets in at position A in the river there, and the flow is going from left to right. And what he wants to do is get across the river. So he goes across the river, and guess what? The current carries him downstream. It takes him a certain period of time to get to position B. But when he comes back across the river, it takes him a longer period of time to transit the river. So as the flow is going across from left to right, if the man went across the river, he went across very fast because he was going with the flow. See, he goes very fast with the flow, but when he comes back, he's going against the headwind, if you would, or the current. It takes him a longer period of time. The differential between those two transit time is a coefficient that we could use to calculate how fast the river is flowing. All right. Well, let's apply that same technology with a pipe. So imagine the picture on the right-hand side is a bird's eye view of a pipe. And what we have here, we have flow going through the pipe left to right, and we have two sets of transducers that are mounted to the outside of a pipe. And what we do here is the first transducer sends out a sound burst, ricochets off the back wall, come downstream to the second sensor. We measure how long it took to get from the first sensor to the second sensor. At the same time, we take a second sensor that's downstream, send a sound burst across the pipe, ricochet, come back down. We measure how long it took to get to this sensor. What we're looking for is the differential of time between these two signals, and that is relative to how fast the flow rate. The faster the flow rate, the greater the time differential, hence again the term ultrasonic transit time. Ultrasonic Doppler is different. Ultrasonic Doppler sends in a sound beam into the pipe and reflects off a suspended particulate matter. Ultrasonic Doppler is similar to, say, police radar. It sends in the beam, bounces off your speeding car, and the beam comes back and tells you how fast your car is going. If there's no cars going, the Doppler doesn't work. So for most of our audience there, ultrasonic Doppler is traditionally relegated to applications with lots of suspended solids or slurry-like applications, which are traditionally not present in an HVAC-like application or chilled water or drinking water application. It's deemed clean from an ultrasonic standpoint. Ultrasonic transit time, on the other hand, works on ultra-pure liquids, no suspended solid required because it's not using any suspended solids, and traditionally works on pure liquids, water, wastewater, but not sludge. So Doppler, heavy stuff, transit time, clean stuff, they kind of meet in the middle, but the transit time technology keeps expanding that. It traditionally works up to application, which is, say, about 2% suspended solids. Now, like every flow meter in the industry, there are a certain set of ground rules to make your flow meter work best. And traditionally speaking, and a faux pas that happens a lot, and a tight plumbing configuration where you're near the coils or something like that, you need to have some straight run of pipe to really do a good job. And traditionally speaking, most flow meters require the traditional 10 and 5 pipe diameters of straight run of pipe to get what you see on the left-hand side here, which is called a symmetrical flow. Now, a symmetrical flow is a flow in this cutaway here where the flow is at the fastest at the center of the pipe and the slowest near the pipe wall. And they gyrate between low and high flow or turbulent and laminar flow, so the elliptical shape may change from blunt to more pointed, but they basically are always fastest at the center and slowest near the pipe wall. So a symmetrical flow profile will have 10 pipe diameters before it from the first elbow and 5 pipe diameters after it, and you'll get this pretty symmetrical flow profile, which will give you the optimum performance of your ultrasonic flow meter, and for that matter, most flow meters. The picture to the right is what we'll call an asymmetrical flow meter. And an asymmetrical flow meter is an application where you don't have enough straight run of pipe. So if we have flow coming up this elbow and we want to put a flow meter here, we could have a problem. As you see, the flow goes through this elbow. There's a short distance and there's a long distance. And as the flow comes through this elbow, it tends to tumble. And so if you were to put your flow meter right here, an ultrasonic flow meter probably wouldn't read anything at all. And most other flow meters would probably read erroneous information. What you do need to do is go downstream about 10 pipe diameters and put your transducer here, and then have another 5 on that side, and then we will have what's called an or symmetrical flow profile. So some of the ill effects of having enough straight run of pipe and not having straight run of pipe are going to be illustrated here as we touch a little bit on the hydraulics in using an ultrasonic flow meter. And the novelty of ultrasonics, of course, is we clamp it on the outside of the pipe. So that right there is a win-win situation, but as I said, you have to do it properly. So the way we work, as we looked at earlier illustrations, we plop the two sensors on the outside of the pipe. And when using an ultrasonic flow meter, quite frankly, it's just a math equation. And things have evolved over the years where you had to be very precise and put certain specific information in there. And now you got a lot of drop-down windows for information. So you basically are going to put in your pipe outside diameter, your wall thickness, your pipe material, your process liquid. It'll crunch the numbers and it will say, okay, this transducer goes here and this transducer goes here. So the spacing of the sensor is critical, but it's predetermined. So if everything works perfect in this symmetrical flow profile, the signal will bounce from here and bounce from here, and this one will go from here to here, and everything will best be perfect, or you'll be operating at your optimum performance. Should you not have enough straight run of pipe, and you have an elbow over here, and the flow profile might actually get distorted. When the flow profile gets distorted, guess what? The signal gets distorted and it may pop up over here. Well, what happens when it pops up over here? It changes the transit time. Now, depending on the brand of the sensor here and the accuracy of the sensor, some sensors might pick this up, but they won't be very accurate, and other sensors will have to move to find the right spacing to make it work. So in an application that you don't have the required straight run of pipe, you have to do something which is called flow profiling. The problem with doing flow profiling is if you're in an application that's required, you may not get the optimum accuracies you're seeking for. Transit time technologies, the ones that you use for balancing commissioning, are traditionally about a 1% type technology. So when you start doing things like this, you may not be as good as that overall accuracy. In some cases, you have no choice because you have no straight run of pipe. You just need to get a flow reading to see what you can do. So we have a whole host of different portable technologies, and in particular, today's audience is primarily in the business of portable flow meters. And what are you doing? You're doing spot testing, you're conducting flow studying, you're commissioning, you're balancing, you're taking care of facilities management. You may actually be doing some energy studies as well. So our discussion is going to focus primarily today on portable ultrasonic transit time flow meter technology. And the key feature for this technology, of course, it's measured from the outside of the pipe. And there are a variety of brands and features, but each of its own has a specific set of specifications that are maybe popular to your particular needs. So we're going to talk about some of those traditional specifications and see how they're applied to use for your particular application. And here we just have some of the more popular brands that are out here. They're not all the brands there, but some of the very popular ones. This is a GE PP878. This is a Fuji FSC Portaflow. This is a Dynasonics DXN, and there's other brands, of course, that go on there. There's Siemens, and there's Flexum, and there's a couple of the brands as well. And these are, however, some of the more portable ones that you're going to see in your particular application. So what are we going to use a portable ultrasonic flow meter for? And these are the things to digest as you look at the different brands of things you can do and you cannot do. Step one, they're used for the discovery process. How much flow do I have going through the pipe? Well, the pump is pumping like this. And if you've been around a while, a pump curve is just great when it's in the shop. When the pump's put in the field and you hook it up to whatever you're hooking it up to, guess what? It changes. And that's why we need to have flow meters to validate pump performance and other performances inside your facility there. So step one, the purpose of the meter is to go through discovery process. This is the flow. Perhaps you need to monitor the flow to size a pump or size a chiller. You need to have statistics just to get that information. In the good old days, you had to put a hole inside of the pipe and stick a probe or a paddle wheel flow meter in there to get that information. Now you really don't need to do that. And the ultrasonic transit time technology has basically moved into a commodity product right now. I've been doing this since 1977, and I've watched it evolve from a toy to a tool, and just about every balancer and most people in the commissioning business have one of these in their toolbox now as a required piece of test equipment. So the industry standards are there, the usability is there now, and different for different model there. And so step one, let's find out what our flow rates are so you can balance something, do a ROI, and the next step is how do you do this? It comes in different packages and comes in configurations. So on an insulated pipe, you've got to remove insulation. It would be nice that you had quick and easy equipment to do a spot check. And what is a spot check? Spot check is you're basically coming to the pipe, putting pipe information into the meter, putting the sensor on the pipe and reading flow there and moving on. So the hardware to do this can be considerably different, and we'll look at that in a minute, other types. Water usage studies. So in addition to balancing your facilities and commissioning your facilities, how much water are you using? Very, very, very popular situation. So everybody here that's doing the commissioning or already has contractors in the facility, once you're inside the facility doing the things you do all the time, such as balancing, commissioning, you have a meter, you'll be asked to do other applications as well. And the first one is, how much water am I using? So you may need to validate a water meter in the front of the building. You may need to validate the effluent or other different zones inside the building. I've done unbelievable amount of waterless urinal studies. Well, it's just water. How much water are we using, and should we upgrade our system to new different pieces of equipment? So water is a hot commodity there. If you have the piece of equipment, the worked equipment, be very popular and other sources of revenue. Energy studies. We're going to touch on that more in a little minute here, but right now the world wants to know your BTU, your energy use. So that is becoming a very popular study. And of course, balancing your hydronic system. And balancing your hydronic system, we sell and we rent these meters, and sometimes a facility person will find out what his flow rates are, but he doesn't know how to balance a system. So we use your expertise to balance the system there. A piece of hardware is great, but you have to have the knowledge to adapt the system and balance it or retool your system accordingly for optimum performances. And perhaps the largest change in the ultrasonic community, transit time community, is the ease of use. Don't know if you've been there as long as I have, but in the good old days, some of the first transit time flow meters that came out were in a big old suitcase there, and you had to put these two giant blocks on its side of a transducer, and you'd actually hear them pinging away, and you had to get the math just right. You had to get the temperature just right, because we're using the exact same equations today that we did then, but they weren't very forgiving. And what's evolved now is there's different dynamic references, so the there's more autopilots today. It's more like an iPhone today than it was a long time ago. So most people can take an ultrasonic flow meter and read a 1 or 2 page operation manual, watch a 5 or 10 minute video, or talk to support people there, and get up and running and having never used the technology before. So those are the things you need to keep in mind when you select an ultrasonic flow meter. And of course, the other thing to keep in mind when selecting an ultrasonic flow meter, we're not all independent millionaires, comes down to bucks. So the price of an ultrasonic transit time flow meter is more than the price of a portable Doppler flow meter, and it is the most common mistake people make. We sell Doppler flow meters as well because we also provide flow meters for other media, such as the water and the wastewater, mining, and pulp and paper industry, so we have a need for a Doppler. You can go online and buy a handheld portable Doppler flow meter for about $1,300 bucks. And everyone will say, my cooling tower water is just filthy, so a Doppler will work. Nay, nay. A Doppler flow meter must have greater than 100 parts per million, 30 to 75 microns in size for it to work. So it's got to have chunks of stuff in it. So an HVAC or facilities management application does not have enough suspended solids for a Doppler meter to work. You have to use an ultrasonic transit. And of course, the transit time flow meter will cost you more. Well, it's more accurate, but it's a different technology, it's a different animal. So to find a flow meter that meets your balancing and your commissioning requirements of your 1% accuracies, you're going to have to pay for it. And the medium-sized price is basically the handheld meters start at about $5,000, and boy, do they go up. You can spend $12,000 on a portable flow meter if you like to. with different brands, and I don't know if you're going to get that many more features there. So a handheld device, such as the Portaflow C you see there, it's about $5,000 for electronics. And then a set of transducers are about $1,000 a piece, and they work in different pipe sizes. We're going to look at that next. So, you know, you're over $6,000 to get a starter kit for a purchase for a portable ultrasonic transit time flow meter that meets your application and your accuracy requirements. So that's a capital purchase. You're going to use it 3 months of the year. Not too bad. You might want to buy it. You can pay for it in time. Pay for it for that job. Or if you just need it to commission a building next week, or if you just need to balance something next week, why buy when you can rent? You can now rent an ultrasonic portable flow meter, the same $6,000 or more flow meter, for $699 a week, any place in the United States next day. If I have a pump down, I need to get a meter tomorrow. I don't want to buy something. I want to find out what's wrong with this pump or what's wrong with this balancing valve. I have no taps on the line. All kinds of surprises. We actually call it around here Freaky Friday, because every Friday afternoon we get calls from everybody that finds out that was supposed to balance a system or commission a system, they got a problem. And we need to have Saturday and Monday deliveries to get you out of trouble there. So the neat thing about it is we've got this great technology, we've got this easy-to-use technology, we have this accurate technology, and you can have it tomorrow and you could rent it, you don't even have to buy it. So there's no more limitation on not to use the technology. It should be a toolbox, and everybody that's viewing this as a maintenance item or a commissioning item or a test tool for you to move forward here. As I said, there's a couple popular pieces of equipment, and as I said, the PP878 is the most popular in the world, and we like it, but it's not new. It's been around for a while, a decade or more. It's had firmware updates and some transducers, but it's still using old math. Some of the newer technologies are getting closer to iPhone, which is one of the very popular meters for most of the balancers now, is the Fuji Portaflow C. And the Fuji Portaflow C has a shoulder strap, which is not pictured here, about the size of a big voltmeter, big display. And now we're getting closer to features that are closer to iPhones. So now the big differences are if you go up a ladder and you want to collect your data and you forgot your clipboard, you can press one button and it stores the screenshot. You see, and everything's stored in an SD card. We'll look at that in a minute. So you can log data at the press of a button. It's small to use. It is 1% accurate, so it's one of the most accurate portable transit time flow meters there. It has a host of drop-down menus there. So you read the one piece of paper front and back, step 1 through 6, and guess what, guys and gals? You're in business. So we can train Pete the plumber in 5 minutes how to use this device, never seeing it before. It's going to get the same intelligent data as someone's been using it for a very long period of time. And that's what the most popular reason for this particular meter, which probably makes up a big chunk of our rental fleet here, is its ease of use. Ease of use and great accuracy. So again, on the picture of the device, on the side here, these are the ports that we put the transducers in, quick disconnect connectors. You can have a 420 milliamp output or input. If you want to use this device as a data logger, you can use this as a data logger too. Want to put some other information here, want the temperature, pressure, you can input it right there and it'll log it right along with your other information. Runs off a battery for about 12 hours. Then after that, it's got a line cord, full color screen. And the bottom of the device here, this is where we store the SD memory card. So you can log all your data on an SD card. So when you download the data, no cable, no software, save it as a CSV file, put it in your laptop, turn on Excel, and open the file. There's your data. Now, all the different manufacturers that have the accuracies that you required will have different frequency transducers. Traditionally, around the 2-inch line of pipe size are 1 megahertz and lower. And traditionally, less than the 2-inch pipe size, you'll have frequencies that are 2 to 4 megahertz. The Fuji breaks this down where they have a small pipe sensor here. That's for adjustable for pipe sizes 1/2 to 4 inches. And the medium-sized sensor is adjustable from 2 to 48 inches. And then we have a Gigantor here, which you won't see in HVAC, but if you're going to do a penstock application. The medium transducer is actually pretty cool in that to do the larger pipe sizes, it actually looks like a one-piece transducer. And that's another key. When the transducer is one piece, guess what? You can hold the sensor on the pipe, get your data, and don't even strap it on the pipe, as opposed to the block and tackle method with some of the other brands that we have there. They could take you 10 or 15 minutes just to put it on the pipe. Or in this case there, we have quick disconnect straps to put it on. But this transducer is kind of neat because it's kind of like a transformer. You can pull it to make it longer so it expandos so you don't have to carry around a 3-foot rail. And it also pops off the 2 separate sensors should you ever want to do a Z configuration, which is the transducers, one in each side of the pipe. And as I said before, here's an SD card that pops out of the bottom, and we used to provide it with 1 gig SD cards, but you can't even find those anymore. It's cheaper to buy a 2 or 4 gig SD card. How much data can you store in this SD card? How about 9 to 12 months worth of data? Wow. So remember the gold days that you could only store 100,000 data points? Now you don't care. You can store all the data you want. It's just a matter of how much Excel software program would take before you overload Excel. You may have to chop up pages. I think they take about 30,000 data points before you're going to make another chart. Walk it into the energy world. Very, very popular. Most of the meters now, you can add on features to your portable flow meter, not only to measure flow. Now you can strap on temperature in your supply and return, and then the device will log flow, temperature 1, temperature 2, calculate the differential of temperatures, and come up with a BTU calculation all logged on your flow meter. Strap on temperature sensors on a pipe. Metal pipe, not so bad. Plastic pipe doesn't work. You have to get beyond the point that we are not looking for the exact temperature inside the pipe. We are looking for temperature differential. And so the temperature sensors provided are already better than, they're a matched pair and better than 1%. And that's the gotcha when you look at the energy management is quality of equipment. In fact, I'm talking at this in the show in St. Louis specifically. If you have unmatched, inaccurate temperature sensors, you botched up the whole BTU calculation. A couple degree differences is going to make a significant change in your overall calculation. But the flexibility of the device is there for you to use temperature monitoring. And moving forward here as far as new technology, how about an iPhone flow meter? Something new that we've released recently. It's not quite as accurate as a Fuji, but if you have an application for 2 to 20 inches, and you have an iPhone, you have an Android, you've got an iPod, go to the Apple Store, download an app, and to your phone, that's free. Take this flow meter, which is basically a rail with no displays and a battery. Program this phone here. It has an app that will basically say, put in your pipe information, adjust your spacing, you put it on the pipe. This guy sells for like $3,500, so it's half the price. It does not have the features of some of the other devices. It does not have data logging. It is strictly a spot checking device, but this is the way things are going towards the future of the world of ultrasonic flow meters. So what do? At Instruments Direct, we've been around for a very long time. We are a distributor, and we also own non-contact meters, a manufacturer. We are all about ultrasonic flow meters, and we're all about working with people in your particular community with ultrasonic flow meter technology, a vast knowledge of your particular application, and can complement you with our resources for those particular situations. So, I talked real fast today. I really do appreciate your time. We have limited access on the chat functions today. Should you have additional questions about what we talked about today, feel free to drop me a line or give me a call about ultrasonic flow meters. Perhaps we can answer your question. And for those who are attending the big St. Louis event in May, I'll see you there. Thank you very much for attending our webinar session today. Liz?
Thanks, Brent. We really appreciate your time today. And as Brent said, we will see you in St. Louis. And please know that this presentation will be up on the website shortly so you can review it and let your friends know about it. We do thank you for your time and attention. If you have questions, here's Brent's number, and you can also get in touch with the office. We'll connect you with him. Again, thank you, everyone.